Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this is my take on Day 16, Part 1 of 2021 Advent of Code. The problem is called Packet Decoder. And here you go. So this one's pretty wordy. You can kind of see there's a lot going on here. And so we're dealing with hex code, binary code, decimal code, all sorts of crazy stuff. All the stuff I teach in the beginning, the first few weeks of my assembly language course. So like understanding how all of this works is pretty crucial to the understanding of how to solve the problem. So basically every one digit of hex code, because hexadecimal is base 16, works its way to 4 digits of binary, and vice versa. 4 digits of binary work its way to 1 digit of hex code. So that's pretty much the whole idea when it comes to that, in just a way of compressing data, maybe making it a little more human readable and whatnot. I'm so sorry. Kind of tiring. Been tiring these 16 days of fun here. So they're fun but tiring. So the problem works as such that you're taking something and you're turning it into binary, and then you're working your way through the binary. So basically you take this E2FE28 here and you break it down into binary and you work it down. First 3 bits are for the packet version. First 3 bits are for the packet ID, type ID. And then the next, and then you keep going 5 at a time until you reach a 0 for the first of every 5-digit packet. You keep going until there's a 0 to lead the thing, and then you know you're done. And so, and then you take the other 4 digits, you kind of concatenate them all together, turn them into an integer, and then you got, in this case, comes out as 2021. So there's using that as my test data. Let me just go down here and here's my solution. You can see the answer comes out as 6. Okay, so the answer will come out as 6. There it is. Let me run this again. So the hard part, or not a hard part, but just understanding part here is that when you get 6 for the packet number, it'll return it here. That basically the index is 24 because I've gone through 24 bits. Technically I've gone through 21, but I moved myself over 3 more to get to 24. And then when I do that, then I get the answer. And then I also have the packet version is 6 because it's these 3 digits. And then if the packet ID mattered, it would be 4. It does matter because when it's a 4, then it goes down and says this is a literal number. So the answer comes out as 2021 because that's what this says. And it would, like, not the answer, but the literal value under the hood is 2021. But the only thing is that right now for part 1 we only care about the packet ID or packet version. So that's why the 6 comes out. So let me just continue on, and then let's see. There's that one. So this one, and then you'll see my dilemma, my data. Save my data. Oh, I guess I'm still running. Breakpoint thing. And then I run this again, and you see it crashes. And the reason it crashes for me is my big dilemma. So I don't have a full solution to this, but if you mouse over this, you say the value is 9, which is the combination of this guy, which is a 1, combination of this guy, which is a 6, and this guy, which is a 2. So it takes into these take into account sub packets. So if that's 2 plus 4 plus 1, 2 plus 6 plus 1, the sum of that is 9, and that's what I get. I'll explain the crashing in a second here. And then if I take this one, keep working our way through this, take this as our data, and run this one. It crashes again. But if I go down here in my code and go, hey, what is my value? The value is 14, which is what is expected again, because if this is 7 and or yeah, 7 plus 2 is 9, plus 4 is 13, plus 1 makes 14. So I have the answer, it's proper. And if I continue on even more now, and with this piece of data here, try this again, quick, you will see that you get 16. There you go. No crash that time. I run this data. I get 12, which is what I'm expecting. And when I do this guy, whoops, this guy, oh, I hear a lot of little things. Okay, run this guy. I get my 23. I do. There's my value. That's my 23. It crashes. And then this big guy here, oops. Oops, I can't run that. Silly goose. Okay, so I run this, and I get out of range error, and I get 31. So there, for all of these, I get my answer, and I can, well, I guess here's my puzzle input. Here's the giant one. Here's the data. It's just a one-liner. It's one giant line. So you would think I would follow suit with this, right? You would think that I would go ahead and run my program. And wherever it crashes, I'm just following my pattern here. And I go, oh my God, look at all this nonsense. And I go, well, the answer is no, because it crashes well before. Oh, it doesn't crash well before. You would just say, oh, 315's got to be my answer, right? So I put 315 in, following what I've just been doing for the previous 4 examples. And I do not get the right answer. And so what it comes down to is I am not reading this correctly somehow. There's some little thing, some simple little thing that everybody's understanding that I'm not, because I do not understand how you know when one of these things end and the next one begins, especially when you work your way into the sub packets. Because it's for me, it's fully understandable that for this you move to a boundary, a byte boundary. So move over, or a hex code or a hex digit boundary. So to say, oh, this was 21 bits. Well, I need to move over 3 more to account for the fact that this ends after the 8, and we go on to the next one. And that makes total sense. But for this one, for these 2, I have no idea. I don't see a pattern. I don't get it. I don't get why you add 7 here. I get why you would add 3 to turn this into a multiple of 4, but I don't know why you would add another byte. And then I'm like, well, what if I just set it up so that if there was all zeros, because a version number can't be 0, can it? And of course it can't. That was my thinking last night. I'm like, well, maybe I'm just not understanding. Maybe at the end here you keep going with zeros, which I understand at the bit level versus the hex code level. But I don't understand how you pad this thing. Same goes here. Like, I can understand adding 1, but why would I add another 0? Why would I add a whole nother byte to this thing? And so that's what's holding it back. That's why it crashes, because I can't understand from one to the next, from one packet to the next. How do you know? Because you would think, again, my data starts with a 0. And then continues with a 2, which means the first 6 bytes are 0, or 6 bits, or however you want to think of it. The first 6 bits are 0, which means that for the start of this thing, wherever it is up here, that the packet version is 0 and the packet ID is 0. And so yes, that blows away all I was thinking right away, right in the first byte, is that I can't just say, oh, the version has to start from 1 and continue on. No, it could literally be anything. And so this is where I'm at right now. I've been talking for 10 minutes. Wow, this is crazy. And so if you have any understanding, I've been looking it up. I haven't found anybody else with the same kind of, I guess, reading comprehension problem or whatever it is. I just don't see it. So if you see it, please let me know. And I appreciate you guys, all your hard work, watching my videos, and always helping me as much as I try to help you guys too. So thanks for listening. Let me just go through the code. Yeah, the code is pretty. Say the code is ugly on top of everything else here, right? So basically, just turn a hex digit into a character, or turn it into a bit string, and just progress through the bit string, and just follow the rules, and then for the sub rules, basically just it's a recursive function, especially down here where you get like, okay, I have sub packets and sub packets. And again, I obviously know how it works. I'm just not understanding some simple little thing here at the end of the day. Oops, there's a comma 2 there. All right, thanks everybody. Have a great day. Talk to you later. Bye-bye.